If you play many games, you most likely come across a few different checkpoint systems. A lot of Mario games use flags as checkpoints. All you have to do is run into them, and your progress is saved. Resident Evil uses a typewriter that you interact with and save your file. Some games use invisible checkpoints that you hit while playing. Others allow you to save just by pausing the game and selecting save. In today's tutorial, we're going to create a checkpoint system. We're going to use good clean coding using blueprint interfaces, a game instance. We're also going to include a saving and loading system so a player can pick up from where they left off if they've closed your game and relaunched it. Now let me show you what it looks like. The player can run around, they start right at the player's start, but if they run over to this checkpoint, a sound plays and you get this little notification in the bottom right that says the game's saved. Now you can go over to the next checkpoint and the same thing will happen. And it doesn't happen twice at the same checkpoint because that's your current checkpoint. Now if we were to die or close the game and reload the game, we'll be right back at the checkpoint that we last left. Close again, open it up, and there we go, at the checkpoint we last interacted with. Same thing will happen for any checkpoint you run into. Quit the game, start it back up, and there we are. So let's delete all this and I'll show you how we did it. Start by opening up your Unreal Engine project launcher. Make sure you're in the Games tab and select third person as your template. Let's leave this stuff as default with starter content and let's name our project to Project Checkpoint. And click Create and wait for that to load. And once that's loaded up, you'll be in your default third person template. The first thing we're going to want to do is create a game instance. Now, game instance is a blueprint class that gets loaded as soon as the player launches the game and stays running until the player closes it. It's a great place to store any variables that you want to be in memory for the entire gaming session, like our checkpoint or any inventory, things that you don't want to change and get reset every time you load a new level. So let's create a new folder. Let's call it Game Settings. I like to create this folder to put things like my game instances and my game modes, stuff like that, keeps it organized. Right click in here and select Blueprint Class. Click this drop down and search for Game Instance. This one right here. Select that and rename it to GI Checkpoint. Perfect. Now if we open that up, it's going to be just a blank, empty blueprint graph. We'll put things in there later. Next, we need to tell the game to use this game instance when it's running. So if we go up here to Edit, hit Project Settings, go over to Maps and Modes, and at the bottom here you'll see this section for Game Instance Class. Switch that to GI_checkpoint, the one we just created, and then we're good to go. Let's go back over to the game instance. Now in here, like I was saying, this gets run once and it just stays running. You could put variables in here if you want them to not change while the player is playing the game, like an inventory or such. But the thing with this is, yes, it gets run once and stays running, but it will get reset when the player launches the game again. So really what we want to do is we want to save these variables into a saved game object so that it stays as a file on the player's computer and we can load from it. The way to do that is, again, go into our content browser, right click in here next to our game instance, and let's create another blueprint. Search for Save Game. Save Game Object. Open that up, or select it, and let's name it SG Checkpoint. This is going to be the save object for our checkpoint game. Now open that up. Again, empty blueprint graph. This is where we're going to want to put variables to save, like our player location. If we put the player location in here, make that a transform type variable, and drag this into our graph, we can get or set. Let's get. Actually, a little shortcut for getting or setting a variable is if you hold in the control key while you're dragging, it'll automatically do a get. And if you hold in the alt key while dragging, it's an automatic set. Just a little bit handier, nice little shortcut. But if this player location is here, if we split that open, we'll see it contains location, rotation, and scale. So it's a little bit better than just a straight up float or vector. It has more information in it. But we could just create a whole bunch of variables that we want to save right here. But something that makes it a little bit easier to pass groups of variables around to different blueprints is a blueprint structure. Let's create that. Again, right click in your content browser, go to blueprints, and click structure. Use f underscore save struct to name it. Don't ask me why f is the naming convention for structures. That's what I learned anyway. Open up your save struct. This same kind of thing. We add variables in here, but these will get passed around a lot easier in one variable. I'll show you what I mean once we set this up. Let's rename the first one to player location. Actually, let's go player transform, since that's the variable we're going to be using. Player transform. Let's set this to a transform. And the second one, let's make it control rotation. And we could save anything else in here too. If your player has an inventory or a health or a number of collectibles, let's type collectibles and make that an integer for a number, and make sure you set your control rotation to a rotator. Nice. Now hit save, and let's close out that structure. So now back in our save game object, sg underscore checkpoint, instead of these different variables in here, let's get rid of these. Let's add a new variable. Let's call it save struct, and let's make the type into the save struct we created, fSaveStruct. Select that, and now if we drag this out and split this, you'll see we have transform, rotation, collectibles, and we can split these even further to location, rotation, scale. You can split that further if you wanted. But as you can see, it makes a nice collection of variables instead of having them all individually listed here. And it becomes even easier when we ask for these variables from other blueprints. So get rid of that. But this is perfect. We have this in here, and by default, you'll see, as long as you hit compile, you'll see that these are all at 0 basically, because nothing's been set yet. That's fine, but we will need to set those numbers from someplace else. If we go back to our game instance, in here we could create custom events, like saving and loading. But these events are going to need to be called from other blueprints. Like for when we hit a checkpoint, we need that checkpoint to tell the game to save our location. To do that, typically you could cast to another blueprint. So if you open up your content browser, let's go check out the third person character. Under third person blueprints, by default, this is where it'll be. If you open this guy up, I'll show you how casting works. So if we wanted to use the save function we just created in our game instance, but we wanted to trigger it from our third person character, we have to first get game instance, and we can't just call that save function here. We need to tell it that we're going to use the one in GI checkpoint. We got to cast to GI checkpoint. And this is going to have to be plugged into something that you're starting with, like jump. If we did that, then it would save every time we jump. We don't necessarily need that, but just for an example. But now that we're telling the game instance that it's the GI checkpoint we created, now we can call that save function. And if you actually double click this, bring you right back over to your game instance where we created that function. But casting it takes a little bit more memory. It's not as fast. If you have a lot of casting going on, it kind of slows down your game. And we're looking to do a nice, cleanly coded saving system. So let's delete that, and I'll show you how we can do this without casting. So delete this event. What we're going to use is something called a blueprint interface. A blueprint interface allows us to interact with other blueprints without casting. So let's go back up into our main content directory. Let's create, just go into our game settings folder again. Right click and go to blueprints again. and select Blueprint Interface. I underscore saving. Open that up. And you'll see it automatically create a function here. This is perfect. We'll use this. We'll call it save game. And let's create another function for load game. Now those two functions we want to use in our game instance. The way to do that is go into our game instance, hit class settings, and over here under implemented interfaces, search for I saving. There it is. As soon as we click that, you'll see we get those two functions we created available to us. Let's click on both of them, double click both of them. Load, save. Now, if we went back to our third person character and say we wanted to hit that save function again, let's do get game instance. Now, if we drag off here and hit save game message, the target is I underscore saving. That's our Blueprint interface. So this function will get fired wherever we tell it to. So this is getting fired, but we're telling it to do it on whatever game instance is using that interface, which in our case is our GI checkpoint, and it'll run save game. It doesn't even have to cast. It's a nice, efficient, clean way to talk to another blueprint. So back in our game instance, let's build out what the load game is going to look like. First, we need to check to see if does a save game exist. Because if it does, we want to load it. If it doesn't, we want to create it. Let's check the slot. So we need to have a slot name. Right click on here, click promote to variable. Move this down so we can see it. And we need to set this as a name. This is something that has tripped me up way too many times. It says slot name. You could name this variable anything you want. Save slot. But that does not make a slot name. You have to compile the variable, compile the blueprint. Then if you look over here in the default value of that string save slot, there's nothing in here. If you leave this blank, saving loading will never work. You need to give it something. So let's call it checkpoint save. This will actually be the name of the file that shows up on our player's computer. Compile that. Now we're checking to see if that save game exists. So let's do a branch. If you hold in B and left click, a branch will automatically get created. Nice little shortcut. Connect both those pins. And for if the save game does not exist, we need to create it. So create save game object. And the save game object we want to use is our SG underscore checkpoint. Let's right click here, promote to variable, call it save ref for save reference. That's looking good. That's all we need to do if there's no save game. But if there is a saved game, if this comes off of true, now we need to load it. So load game from slot. Now they actually see load game. You'll actually see async load game from slot as another option. The same goes for save game as well. If you type save game to slot, you also have async save game to slot. The way these async ones work versus a regular save is a regular save or load stops the game. It will hang and wait while you're loading. An async load or save will let things load or save in the background while the player keeps playing the game. That works pretty good for saving. I'm thinking Horizon Zero Dawn or Alan Wake 2 allow you to run up to a save game object in the world, and you can hit the quick save button and just keep running away, and it'll just save in the background. That's really good and really smooth looking. But for async load, you might not necessarily want the game to load in the background while the player's playing, because maybe we need some of that information that's being loaded in order for the player to play properly. So I usually steer away from async load. I just want the game actually to wait until everything's loaded. But async save is pretty smooth. So this one does have some pretty cool use case scenarios. If we want to actually make this an option, if we want to be able to allow us to load or save async or regular, let's go back into our Blueprint interface and add a Boolean to these. So under load game, add an input for async, question mark. Same thing for save game, async, question mark. We compile that and go back to our game instance, you'll see we got that Boolean pin now on load game and save game. That will make it so that when we run this, it'll actually check to see if we want to run async or not. So let's create a new branch. Hold in B, left click for a branch. If this pin, let's plug that in, is true, make sure we plug the execution pin in here. If async is true, let's async load. If async is false, let's regular load. Make sure we plug in our slot names to both of these. We're going to ignore user index for now. That's like on the Nintendo Switch, how you have different users that can play different games. That's how user index works. We're not going to go over that today. But after we load game from slot, we need to cast to SG checkpoint to make sure we're using the one that we created. And then let's copy this up into here to make sure that that variable is up to date. This just needs to be copied right up to here because it's going to be the same thing. And we can actually do something on completed later to show that the game is done loading or done saving off completed. But for right now, this is going to work great. Let's create our save game function. Off of event save game, we want to, well, let's first create that branch for the async. Plug both those pins in. If it's true, we want to async save game. If it's false, we want a regular save game. Make sure we plug in that save slot to both of these. Also, we need to tell which object we're saving to. That's why we set these variables up here. Pull off your save ref, drop it in there, and drop it in there. Compile, save, and that's all we need to do for now. Let's comment these. Actually, let's organize it a little bit. Whoops. Now, if we highlight everything and hit C, we can comment. Let's call it load game. And do the same thing for down here, save game. That's how we want it. Now, what we want to do, though, is load the game as soon as the game starts. Now, a lot of blueprints have a function called event begin play. But a game instance doesn't have that. What it has instead is event init for initialize. Works the same way though, it starts as soon as this blueprint gets loaded. All we need to do is pull off of there and go load game, call function load game. And we don't want to async right now. This, as soon as the game loads, is going to load our game, which is then going to either create a save game object if it doesn't exist, or if it already does, it's going to load that save game. Perfect. Next, we need to create our actual checkpoint. Open up your content browser and go back up to the main content window. Right-click, create a new folder, call it Blueprints, and open that up. In here, let's create a blueprint class, select actor, let's call it BP checkpoint, and open that. This is just going to be an empty blueprint. Let's make sure we're selecting the top item here and click Add Static Mesh. There we go. Now, if you go in here, you can pick a mesh that you want it to be. In the demo, I used the statue. Select that, and there's our statue. If we look back in the map itself, let's open up our content browser. I'm hitting Control Space, by the way, to bring up that content browser. Drag one of these out into the world. There's your checkpoint. It's a little small. You can scale that up if you want. Go back to your checkpoint object. Under scale here, let's go 3 by 3 by 3. A little bigger. There we go. If we hit play, we can see that it's a decent size. You can make this whatever you want. You could even make it invisible. You don't have to use a static mesh. What's actually key is what makes it so the game knows that we're hitting that checkpoint. So back in our checkpoint, let's add a box collision. Let's move it up a little bit so it's level with the floor. Let's scale it up to like 75 by 75. A little bigger, 100 by 100. If we compile and go back to our map, you can see that that box is visible. That's our overlap box that triggers when we hit the checkpoint. That will go away once you play, but that's good for your reference. We can actually make sure that it's knowing that we're hitting it by going back into our checkpoint. Let's go over to the event graph, right click on our box collision, go to add event, and on component begin overlap. This will trigger when anything overlaps that box. We want to make sure that that thing overlapping is the player character. So drag off of here and go cast to third person character, or whatever character you're using for your game. Now, if it fails, that means it's not the third person character interacting with our checkpoint. But if it is our third person character, let's do a print string. This is a nice way to test. So it will say hello if we are interacting with that checkpoint. And there's our hello up in the top left. It'll happen every time we interact with this checkpoint. Perfect. So that means that's working. What we need to do next is now save our player's location to the game instance and save game object. So from here, instead of casting, remember we have get game instance, and we can do anything that we have in our blueprint interface in here. But we don't have anything yet that sends variables over to the game instance. All we have are save and load functions. So let's create a new function. So over in our blueprint interface, let's create a new function called update save data. And go back to our checkpoint and call update save data. We need to pass over some variables through this function. So back in our interface, let's edit this and create a new input for save struct, and make sure that fsave struct is here. So if it's not, fsave struct, click on that, compile that, go back to our checkpoint. If it's not showing up here, right click on this function and just click refresh nodes. There it is. So we're going to want to send variables over to this save struct in the game instance. Now we could split this open. You can see, remember, we have the save struct, the player transform, the control rotation, our collectibles. So we could find these from here, but this is our checkpoint object itself. The player's location and the player's collectibles, the player knows those best. Those are already in the player. We don't necessarily need the checkpoint to know those. So let's go over to our third person character. If it's not still open, remember it's in third person, blueprints, and there, right there, the third person character. And right here, we need to send over some information that fills up our save struct. The location, rotation, collectibles. So let's create a new function in our third person character. Over here, click plus and do set save data. And let's create an output for this because we're sending this data back out to another one. So remember, we could just add these variables, but we already have a structure for this. So save struct and search for fsave struct. Click that. And now let's split this open. So we have transform, rotation, collectibles. All we have to do is get actor transform. That's our player's transform. And then get player controller. And then get control rotation. Plug that in there. And for collectibles, we didn't create any collectibles for our character. This is really just whatever you want to save that your character has. But for this example, let's create a new variable over here. Let's call it collectibles and make that into an integer. And if we compile that and say, like 10 collectibles is how many we have so far. Let's hold the control key, drag this in, and then plug that into the collectible struct. Now that will set these variables so that we can grab them from somewhere else. Back in our checkpoint, if we drag off of the third person character pin here and say get save, is that what we called it? Set save data. Set save data. It will have a save struct pin. Now if we recombine this, it's the same thing. That just passes all those variables right on through over to our game instance. Let's go over to our game instance now. We need to use that function that we created for update save data. Double click that and you'll see it already has our save struct here. So what we need to do is grab our save ref, which if you remember, this is the save game object, which if we go to the SG checkpoint, has that structure in there with all those zeros. Let's set save struct. This will set this with new values, and those new values are coming from here, which came from our checkpoint that we just grabbed from our player character. Now our save game has the correct variables, the current up-to-date variables. But we want to save that to the computer, remember. So all we have to do is trigger the save game function. Save game. This top one, call function save game. Do we want it async? Well, we can decide that later. Actually, we can decide that from the checkpoint itself. So let's edit this blueprint interface function. Back under I_saving, update save data. Let's add a Boolean for async. Back in the game instance, let's plug this into async so that whatever we set when we called this event will then carry right on over to the save game. And where we want to set that is over here in our checkpoint itself. So if you wanted it to be an async checkpoint or a non-async checkpoint, you could just check that right there. Let's make sure that the game is doing everything we want it to. So let's add we already had a print string after this, knowing that we can interact with it well. Let's go to the game instance and make sure that we are saving everything. So after save game, let's do a print string here. Let's call it saved. Compile that and hit play. All right, it's saying saved. So that data should be saved on our computer. We can actually check to see if that's the case. If you open up your file browser, go to where your save game is, you'll see the name of your game project that we're working on, Project Checkpoint. If you go under saved, save games, there it is, checkpoint save. That is the file that's containing all the variables that we saved to our computer. And those are getting loaded back up when we open the game every time. Now all we need to do is really use those variables. So every time we start, yes, it's loading that info, but it's not doing anything with it. So let's do that. What we're going to want to do is in the third person character, we need to use the data that's getting loaded. Let's create a new function. Hit the plus sign over here. Use save data. And let's create an input on this for the save struct. Again, we keep using this. It's really nice just being able to pass all those variables through in one pin. If we split that open, these are the things that our game instance has. So let's come off of here and do an equal to, and then off of this, do a make transform. What we're doing right here is we want to make sure, we want to check to see if the transform that's in the save game is 0. Because if that's the case, that means we don't have any save data yet, because everything's by default set to 0. Hit B and click to create a branch. Plug this in here. So if it's true, if it's 0, we don't want to do anything. But if it does have data in it, we'll want to use it. So off of false, do set actor transform and plug this into that transform. This will set our player character's location. After that, let's set our collectibles. So drag your collectibles out with Alt and just drop it in here. Let's set your collectible number to whatever's in the save. And finally, let's get player controller. set control rotation, plug this in here, and plug the new rotation into the control rotation that has been saved. We need to call this function. So the good place to call that would be right after the player starts up. So let's use save data. But we need to give it the save structure, all those variables that the game instance has, because it just loaded them. For that, let's get game instance, but we need a new function that will spit out our save structure, because right now we don't have anything that's doing that. These are all receiving information. Back in our Blueprint interface, let's create one more function. Let's call it get save data. And for get save data, what we want to output is the save struct of type, well, let's spell that right, of save struct. So using F does actually make it really easy to find out of everything because it's the only thing that starts with an F. Now back in our game instance, you'll see up here we have a different colored function. If we double click that, it'll become its own separate function. All we have to do here is drag our save ref out here, get save struct, and plug that in. And now, since this is already, by this time, the game has already loaded the save reference, it already has in memory the current variables of save struct. And it's going to spit that out to where we call it, which is in our third person character. If we do get save data, you'll see right here, it's got that save struct pin again. Just plug that in here. And now, let's test it out. Look at that, we're already next to the checkpoint. Now let's hit that checkpoint again from a different spot. And it says saved, so let's close the game. And if we play the game again, there we are, we're right next to the checkpoint. Checkpoints are working very well. Let's add another one. So back in our content browser, go to Blueprints and drag this checkpoint out. Let's put it up here and hit play. All right, we're at this checkpoint. Let's go over to the checkpoint on the hill. It says save, let's quit and play. There we are, checkpoint. The next thing we can do is create a widget that shows the player that the game is saving. So in our content browser, let's go to the top folder again and create a new folder called UI. Open that. In here, right click and go to User Interface. Click on Widget Blueprint, select User Widget, and let's go W_saving. Open that. And you'll just have an empty blueprint graph here. Let's go up into the palette and search for overlay. This will just overlay whatever we put into it onto the screen. Let's add some text to this overlay. Drag this out into here. There's our text block. Let's call it saving. ... And let's set it to align right and align bottom, so it's bottom right. Let's add some padding. Let's go 100. That'll bring it up to a little bit off the corner. And nice, we can leave that alone. Let's go to our game instance again and go back to the event graph. And let's start using that save widget. Let's create a custom event. Right click, custom event. Let's name that to show save widget. And after show save widget, let's create a widget. Create widget. Select W_saving and promote that to a variable. Call it W saving ref. Compile that, and we've created our widget. But actually, let's disconnect this. You can just drag, you can just hold in Alt and click. That deletes that pin. You can actually also hold in Control and move that pin around, but we just want that pin away. So leave this here, because what we actually need to do is make sure that we haven't already created this variable yet. So with this variable, drag it out and drag off of it saying is valid. Use the one with the question mark. Plug that in. If it's not valid, then obviously we need to create it. But if it is valid, we'll need to show it. So let's say add to viewport off of is valid. And we need to call this from somewhere for this to show up. So let's do it after saved instead of this little saved print string. Let's do show save widget. Now let's test that out. Hit play, and let's run over to this checkpoint. There we go. It says saving. Now it's just going to stay there because we didn't tell it to hide yet. Let's create a new function for that in our game instance. Right click down here, create a custom event, call it hide save widget. Let's grab our W saving ref and remove from parent. Simply enough. We just need to call that somewhere. Let's call that after a certain amount of time. Let's put a delay in here of 3 seconds. After 3 seconds, let's hide the save widget. You can actually plug this in either side. Compile, and let's test that out. All right, so saving, and then it's gone. And that one lasted for 3 seconds. And 3 seconds. Let's hit this one and then go right over to this one. This one's doesn't appear. It still disappears after 3 seconds. What we really need to do is create a new widget each time we hit it. Let's test it out. Saving. And it disappears. Let's try it with this one again. 3, 2, 1, and it's gone. Now, a problem I'm noticing is if you hit this checkpoint, 3, 2, 1, it still goes away, even though you just saved on this one as well. It's still saving, even if we just hit this one. Just in case you have checkpoints this close, you probably won't, but just in case, you don't want this one's widget to take away this one's saving notification. So the way we can do that is change this to a retriggerable delay so that it gets re-triggered each time it's called. Let's put this in over here. Actually, in order to add this widget again, we'll need to get rid of the one that's already there from the other checkpoint. So first, before we add it to a viewport, let's check to see if it's already in viewport. Is in viewport. Create a branch. And if it's in the viewport, we actually want to remove from parent. Actually drag off of this, remove from parent, and then add it to viewport. But if it's not in the viewport, let's just add to the viewport like it was. And this actually needs to get plugged into that branch. So if the saving reference has not been created yet, let's create it. And actually, we need to add to viewport here as well. Because if it's our first checkpoint, it's copy, paste. We still need to show that viewpoint, that checkpoint. Plug this into the delay. And up here, if the widget does exist, we want to check to make sure it's not already in the viewport. If it is, let's get rid of it and add a new one. But if it's not in the viewport, let's just add it to the viewport. And then hide save widget. Oops, we're getting an error here. If we compile, we just got to plug this in so we actually know what we're adding to viewport. Now let's test it out. It's showing saving immediately because we are in that checkpoint box. And let's hit it fresh. 3, 2, 1. It's gone. Now 3, 2, 1, 0, 3, 2. Now it went for a full new 3 seconds. So 3, 2, 3, 2, 1, There we go. Now it's working well. It creates a new save widget each time it needs to. That's just good practice to check to see if widgets are already in the viewport before you do something with them or add a new one. It's a good thing to know for down the road for other projects. Now, something that you might be noticing is that as soon as we start the game, it's saving again. We don't necessarily need to do that because we just loaded the game. We don't need to immediately save upon loading. The reason it's doing that is because as soon as we load in, the checkpoint says, oh, you hit our overlap box. We need to save. And we don't want to do that because we don't necessarily want to keep on saving as soon as we load. And also, we don't necessarily need it to save each time we hit the same checkpoint. Now, you could do that if you wanted to. If you wanted to save each time a player hits it, if they wanted to go back and save their progress, or even you could create an interactable checkpoint that saves when you interact with it. But for our purposes, we don't necessarily want it saving as soon as you launch. And if you see, if I didn't move and I start again, it messes up our camera angle. In order to avoid that, we will want to check to see what the current checkpoint is. So let's save our current checkpoint into our save game. Let's go back to the beginning, basically, to our save game object. Let's create a new variable here called current checkpoint. Now, you could add it to your save struct, which would probably be a good idea. But I'll show you how to do it this way, just so you know how. And it also shows how easy save structs are to work with. So for current checkpoint, let's make that a BP checkpoint reference. Compile that, save it. And where do we need to set that? Well, we basically need to set that when we hit a checkpoint. So in our checkpoint object, when we update the save data, it's sending over a struct, but we also need to send over the current checkpoint. So let's edit that in the interface. For update save data, let's add another input called current checkpoint and make that a BP checkpoint object reference. Nice. Back in our checkpoint, now there's a current checkpoint. To send over what checkpoint is the current one, we just need to type self, a reference to self, because this is our checkpoint. And this will send over itself as a reference to the game instance to save it as the current checkpoint. So in our game instance, when we do update save data, we need to update not only the save struct, but also the current checkpoint that's in our save game object. So drag off of this, set current checkpoint. Make sure you connect these pins and then connect this one to here. And that will save our current checkpoint into memory. It still will save automatically right away because we're not checking to make sure it's not the current checkpoint when we overlap with it. The way to do that is go into our checkpoint blueprint again. And before we even check to see if it's a third-person character that's overlapping with us, we can get the game instance, copy and paste this over here, get save data, and like we did for our update save data, we need to add the current checkpoint to this function. So back in the interface, for get save data, let's add an output for current checkpoint. And make sure it's BP checkpoint reference. It automatically set it for us. Back to the checkpoint. Now we have this checkpoint. So basically we need to see if the current checkpoint that's here, type equals and self again. Plug this self in. So if the current checkpoint is equal to this checkpoint that we're on, let's create a branch. If that's the case, we don't want to do anything. But if it is not the same, let's do the save. Let's test it out now. And we got a crash. Let's find out what was going on. So what we forgot to do is when we get this save data from the game instance, this isn't getting anything yet because we didn't set it. So back in your game instance, let's check on that function of get save data, this one right here. So we plugged in our save structure, but we did not plug in the current checkpoint yet. Get current checkpoint, plug that in. Now it should work. There we go. So run up to this checkpoint. It's saving. And it doesn't save again when we hit it. This one will save. Let's close the game, load it back up. We don't get a save right away, which is perfect. It's not immediately saving on load. And then this one, working perfectly. Now, if we want to account for an async save, let's do that. In the game instance, in our event graph, let's organize this a little bit. Let's highlight this and press C and call it update. And let's highlight this and go show save widget. Highlight this, hide save widget. Looks a little nicer, easier to see visually. Looks nicer. So it's showing the save widget when we save the game to a slot, but it's not doing anything when we async. What we want to do is copy this, paste it up here, and show the save widget while it's saving. And hide it when it's done. Hide save widget. Actually, I just remembered this. We're going to need to check to see that this is valid when we remove, because we don't want to try to remove something that already got removed for some reason. So is valid. If it is valid, remove it from parent. Just good practice to avoid errors. So let's try async. And in order to do that, go to our checkpoint, and in the event graph, let's tick async. That way we're doing an async save when we get a checkpoint. And it's working. If you look at the bottom right screen, saving is flashing very quickly. That just shows you that we're saving so little data that it really doesn't take long at all to save. If you still want to do async save, but you actually want it to show for a second, let's add a little bit of an artificial delay here. So after the async is completed, add a delay. Let's do a 2-second delay, and then hide the save widget. There. Now it's staying for 2 seconds and going away, even though it took very little time. We just added that for a visual sake. And that's about it. If you wanted to customize this a little more, you could place as many of these as you want. You could, if you wanted to make this an invisible checkpoint instead of having something that you interact with, think of like a lot of horror games, a lot of survival horror games. You'll hit checkpoints and maybe it will show that widget, maybe it'll show nothing. You won't even know. You'll just get reset to this point if you die. Easy way to do that with the checkpoint we've already built is if you click on the checkpoint, hit details, and if you click on the static mesh part of the blueprint, here you can see our statue. Let's just click on it and click clear. And now there's no statue. If we play the game, it's not there, but if you remember where we put it, it's about here. You'll get that saving icon in the bottom right. And it won't happen again because we already went through it. So if we were in a horror game, we were going along and then we died, start the game back up, we're going to be right where we wanted to be, right where the developer chose for the last checkpoint to be. So that's just a little bit more customizable bit of the checkpoint system. I mean, you could even make this box bigger, so scale it up if you want to make the checkpoint a really large area. Remember, it only saves when you first cross the border of this area, so make it a size that makes sense for your game. So I think that about wraps it up. If you have any questions, any bugs, leave them in the comments below. And keep an eye out for more very epic videos. I got more stuff in the works. Right now I'm working on a behind-the-scenes devlog for my newest game, Vapor Drive. Keep on the lookout for that. It's going to be kind of cool. Have a good one. Thanks for watching. Peace out.